For the purpose of parallelism and better discussion, allow me to show you the two methods in solving or evaluating the limit of a quadratic trinomial z squared plus z plus 1 as z approaches to negative 1 plus 2i. The two methods is, of course, the first one is with the use of the limit theorems. It might be longer than the second one because we need to really examine the step-by-step process of applying the limit theorems, or the second step, which is direct substitution. It's up to you which you will be using, but of course I'll be showing the two of them just to make some differences and of course to make this video more comprehensive. The first one here is the limit of your quadratic trinomial z squared plus z plus 1 as z approaches negative 1 plus 2i. Notice that our z sub 0 is expressed as a complex number. So by limit theorems, again, first is limit theorem. You might want to skip this if you don't want to view this one and automatically proceed to the direct substitution. But please, if you can, please view this as well for you to be able to differentiate the two. For the limit theorem, we have here the limit of your z squared as z approaches to negative 1 plus 2i plus the limit of your z as z approaches to negative 1 plus 2i. Take that we have the same z sub 0 plus the limit of 1 as z approaches negative 1 plus 2i. So we're distributing the limit together with the limitation for your z or z sub 0. Now for this, simply implement it by part or by term. So you have here negative 1 plus 2i, you're getting the square of that. Second here, plus negative 1 plus 2i. And you have here, the limit of the constant is the constant itself. Okay? Now for this, of course, you can actually solve this first because we need to apply the correct exponentiation for that. We know that that is equal to negative 1 plus 2i times negative 1 plus 2i. So allow me to do it step by step. Again, you might want to skip this if you would like to. Negative 1 times negative 1 is 1. Inner terms, or I mean, let's say outer terms, minus 2i. Inner terms, minus 2i. And last terms, we have plus 4i squared. We need to do this properly because I squared, as we know, I squared is actually equal to negative 1 because your I is equal to the square root of negative 1. So this is equivalent to 1, then minus 4i as you combine these two. And you have here plus 4 times I squared, which is this, negative 1. So you have here 1 minus 4i minus 4, which will give you a result of negative 3 minus 4i. This is just the value of your first term. So to continue, you will have here the value of your first term is negative 3 minus 4i. Second term plus negative 1 plus 2i. And the third term plus 1. Removing grouping symbols, negative 3 minus 4i minus 1 plus 2i plus 1, which would give you, combining the real parts, this is actually 0, right? So you have minus 3, and the numerical coefficient of your imaginary part, so you have, that's negative 4 plus 2 is minus 2i. This is the limit, okay? This is the limit of the value of the given limit here of the complex function z squared plus z minus 1 as z approaches to negative 1 plus 2i. Okay, I told you I'm going to show you two methods. Allow me to share here the other method, which would automatically use direct substitution. Okay, you may of course use this if you would like to. Okay, there are just some important cautions if you're going to apply this, because this might not be true for all, especially if your function is a piecewise function. But since our function here is quadratic, so we can just simply do that. So with direct substitution means apply that here and here. This is equivalent to the square of negative 1 plus 2i. Then have here plus negative 1 plus 2i and plus 1. As you can see, this is the same as this second step here without even applying the limit theorems there. Now, basically, this would of course equivalent to that, and all of this will just yield to the same result. So just simply complete this, I would just simply like to complete that again. It's just equivalent to this. So you have here negative 3 minus 4i plus negative 1 plus 2i plus 1, negative 3 minus 4i minus 1 plus 2i plus 1. Again, it's just negative 3 minus 2i as well. So I have here the two methods, direct substitution and the use of your limit theorem here. Okay? Basically, we're just using limit theorem because we had a video and the discussion for that, so that it's applicable to this few examples here. Of course, the origin of your substitution, of course, uses the concept of limit theorems. Thank you very much for watching.